we are moving on to chapter 5.
These are tears coming from my eyes.
So I just had students do this ACT style type of warm up. Are you talking about Maya? ACT style type of warm up that the juniors have been working really hard on while I've been not here. Now, somebody said to use guess and check. You can do that. You're given options. And so if you're thinking of all the possible ways to form a rectangle with like the smallest side and which one of these could have an area of 32 and a perimeter of 24, the smallest one is 4. Yeah.
Oh, so smart.
Now,
36.
I'll quickly walk you through how you can algebraically do this, but it takes a while. And remember, you got to try to do like a minute per problem on the ACT. So, all right, let's just say X is my shorter side. To find perimeter, you just double each side, add them together. We know the perimeter is 24, and we know the area, which is the X times Y, is 32. So you have 2 equations, 2 variables. You could do like a little substitution here, which I think, Brianna, I saw you doing that, which is beautiful. That's a great way to algebraically do this. So I solved this one for Y. Doesn't matter technically which one you do, but Y is the same as 14 minus, half of 24 is 12.
Ooh, all right.
Woo!
Got it.
I'm a little rusty.
You get a break today.
Okay. And then we could substitute that in here. Thanks. So forgiving.
Nice. Is that what you just said?
So forgiving. And you could solve this algebraically for X. Ends up being a quadratic. That's pretty quick and easy to factor. And you end up getting 8 and 4, depending, I mean, obviously X could be either of those depending on which side you call X. But basically the dimensions is 4 by 8. That would give us a perimeter of 24 and an area of 32. So of the shortest, in either case, it would be 4. But you could definitely, I like this one because you could definitely like think of all of these possible lengths. All these possible lengths and how they would form a triangle and how they'd form an area of 32. And some of them obviously like don't have that correct parameter. So you could also do this really quick by guessing and checking, and that's A-okay to do on the ACT. All right. Good stuff. So I just passed out the chapter 5 outline. So you'll see it's kind of like a shorter chapter. And it's still trig, but we more move on to like applications of using like the trig identities. So today we just are gonna stick to pretty like basic, the fundamental identities. And when I mean fundamental is you guys already actually know these identities. So here's the other good news too. These are the ones you guys already know. Okay, this is the list you already know. I even made you, I know it's been a while, but I made you like prove some of these a little bit in chapter 4. Like, do you kind of remember proving the Pythagorean identities? It came from doing the Pythagorean theorem and then looking at like, hey, I could rewrite b over c squared as tangent squared or whatever like that. You guys actually like proved those, that the sine squared of any angle plus the cosine squared of any angle is always 1, and then like their reciprocal ones. You already know all the reciprocal identities, I hope. Quotient identities. This, again, we know from the unit circle that tangent is the same as y over x. And if y is sine and x is cosine, you could also say tangent is the same as sine over cosine. And that would work in any right triangle application. You don't have to write this down, but sine would be a over c. Cosine would be b over c. Tangent would be a over b. Or I could also do sine over cosine and I get that same ratio as tangent. Okay. We did these co-function identities. These will come up a whole lot. But we basically like talked about in the right triangle, how I made you prove this was like, if we have a right triangle here and this is some angle, this angle is obviously going to be 90 minus whatever that angle is. So we talked about like how the sine, which is the opposite over the hypotenuse, would be the same as like the cosine of this angle adjacent over hypotenuse. So that's kind of how we like proved those. I'm not too worried about the proof. You won't have to prove these to me. It does help you kind of like conceptually understand where they come from when we did like that right triangle application stuff. And I don't even make you memorize these. You get a cheat sheet.
Thank Christ.
Wow. So
kind.
this is your new unit. I mean, this does have a little mini unit circle.
Can we use this on quizzes?
Yes.
Yes!
Oh my god.
Oh my.
This is your.
She's learned.
Oh.
Memorize the unit circle.
So it's just these identities. Well, first of all, when I pass this out to you, you might be like, "Oh my gosh, there's so many identities."
Oh my gosh, there's so many identities.
I don't care. I don't have to memorize them.
We
That's all
don't.
that matters.
We don't know all of them yet,
Yeah.
and we're not going to do all of them right now. This is basically all of what we're going to do chapter 5.
It does have tangents on there.
Oh.
Put that on there.
Can I use this on the retake quiz?
Yeah.
No,
No, do it.
not in chapter 5. In chapter 5.
What about chapter 6?
I don't think you need them in chapter 6. You won't need them.
If we ever do, can we use them then?
No, I don't know. Yes. You'll always be given these identities.
Okay, let's go.
Okay,
Solid.
now let me just say, and since this class is called pre-calculus, we're always thinking what we need to know for calculus, right? For calculus, all you're expected to know are the reciprocal identities, the quotient identities, and the pi thing. Those are the only ones you have to know.
Nope.
So that's why I don't really make you memorize the rest. And these, this one especially, these actually don't even come up that much in calculus. This one does, that the sine squared of an angle plus the cosine squared of that same angle, that's always going to be 1. Okay, so if you look at the sheet I just passed out, so for sake of this video, Natalie, I just passed out this sheet. I'll get it posted on Google Classroom. We know these ones so far. We know the reciprocal identities, the quotient, the pi thing, the co-function. Even odd, I can't remember if we've done those. I don't think so.
We didn't notes, but I don't think we ever did them.
Did I put them in this note pocket? The even odd? Yes, I did. Okay.
Well, yeah, that's obvious.
God, look at that beautiful unit
All right, so really quick, let me just explain the even odd ones. Because we've, like I said, we've done proofs for all these. The even odd, so basically, if you know your quadrants, this makes sense. So let's say I have some angle, they're just using u as a variable. Let's say I have some angle here. The sine of the opposite of that angle, so let's say this angle is 45 degrees, so negative 45 degrees. Since we're talking about sine, it's going to be the opposite of this value. Cosine, it's going to be the same, right? Because cosine's positive in both of these.
This is true.
Tangent's going to be the opposite value, and then all their reciprocals. That's all those identities are. But like I said, you don't have to memorize them. They're right here. Okay, so let's get into it. So basically, all you're doing in these types of problems, you'll see, is we're going to use these identities to help us solve problems. We've solved problems like these ones before. So it says, use the given conditions to find the values of all 6 trig functions. You guys were used to like drawing the right triangle, doing your pi thing to find like the missing side here and like fill in the other 5. Okay, but we're not going to do that. We're going to do it using the identities. And actually, this is a better method than drawing the right triangle because these give you like all the algebraic possible values, and then you have to like think of what quadrant we're in here. Okay, so for this first one, we know the secant of some angle. Oh, another thing we do in this chapter is we throw in a lot of different variables for angles. So usually with right triangles, we use theta, okay? You're going to see x a lot. You're going to see u a lot. You could see some other Greek symbols. Sometimes there's T, there's a theta one. T, I've seen T. So don't let that throw you off. If the variable is right after the trig function, that's meaning an angle. That's like I call it the argument. We're taking the secant of some angle u, the argument here. Okay. So I know the secant of some angle is -3/2. And I know that the tangent of that angle is greater than 0, which that means it's positive. So from that information, if secant is negative and tangent is positive, what quadrant would that have to be in?
3.
3. 3 is the only quadrant where tangent is positive and everything else is negative. Okay, if everything were positive, that'd be quadrant 1. All right, so this little piece of information, folks, that's just telling you that we're in quadrant 3. Again, normally we've sketched a picture. We're not going to use that. We're going to do the identities. So I don't really have a method to how I do these. I just kind of like piece by piece do what's easiest. So like if I know what secant is, I'm like, hey, I can easily find its reciprocal. Cosine would be -2/3. Now you don't have to write these down, but for your notes you can if you want. Technically, what you just used was the reciprocal identity. I'm just gonna go like that for now. Technically, you just used an identity there to find cosine, and it's the reciprocal identity. Okay. So keep that list out that I just passed out to you. So now I'm looking at some identities, and I'm like, all right, I know what the cosine is, and I know what the secant is. So which identity could I maybe use to find one of the other ones? And I got my eyes on this list here, and I'm like, okay, well, I just used this. Oh, not that one. I just used this one to get the cosine one. I could figure out tangent and cotangent, but I don't know what the sine is. So maybe I should try and find the sine next. So then I look down here and I'm like, hey, I know that the sine squared of an angle plus the cosine squared of an angle is always, always, always 1. Or we could use this one too, since we are given secant, and we could find tangent next if we wanted to. There's a lot of different ways you can do these problems. That's the thing that sometimes students get confused on, is sometimes there's more than one right step. Okay, so I'm going to use the Pythag identity. So I'm just going to jot it down right here. I know that the sine squared of any angle plus the cosine squared of any angle is always, always, always 1. And that one is just easy to remember. It comes up a lot. So essentially, you can algebraically find the sine by plugging in the cosine, and there's no like right triangle drawing needed. Okay, so sine squared is my one I'm trying to find. So the cosine of u is -2/3. So the cosine squared is you would just have to square that number. Okay, are we okay with that? That's the same as squaring the cosine of u. This, you don't have to write this down, but this is the same thing as this. This is just how we write it because we don't want you to get confused if we wrote it like this. Now it's notating that just the angle is being squared. So how we square the whole trig function is we put it in between the trig function and the argument. In calculus, we do this a lot. I make them rewrite it like this with their types of problems. Okay, that is the same thing as that. So we're squaring the actual value, not squaring the angle. Make sense? Okay. So -2/3 squared ends up being 4/9, positive 4/9. And then we just algebraically solve this for sine. So minus over the 4/9. So think of 1 as 9/9 minus 4/9, we get 5/9. Any ideas of how we could solve for sine? Square root. Good. Yep. Then get rid of that square. We're going to square root. Now, anytime we square an equation, we need plus or minus. but we're going to decide plus or minus depending on what quadrant we're in for sine. So we get root 5 over 3. So is it going to be positive or negative if we're in quadrant 3? Negative. Everything's negative in quadrant 3 except tangent. So that's because we're in quadrant 3. There's sine. Sometimes I like make a list too at the bottom, like I do my, my basic 3, sine, cosine, tangent, and then fill in the blanks as I go. You can do that if you want, but okay. Now that I have sine, what would be an easy one to find? Tangent. What would be even easier? Cosecant. It's reciprocal. Yep. Cosecant would be, tangent's not bad either, but cosecant is going to be its reciprocal. The only thing I don't like about the circuit I gave you is they left some answers not rationalized.
Yeah.
But guess what? When you get to calculus, you get to stop doing rationalized. I know.
You're giving us
No, don't say
calculus level homework.
That was a calculus circuit, yeah. But you guys know how to do it.
That's pretty easy.
Shut up, Wally.
Wow.
All right. Technically, that was a reciprocal identity. Yeah, my calculus students did that same circuit early in the year. Oh, they didn't know anything.
Yeah, let's
They
go.
didn't. I'm not kidding. That's why we did it. It's okay. Now they do. And now it's all good. It's how you guys do. Oh, I forgot to do my flashcards today.
Okay, go get him. Go get him.
I did it.
Did you actually?
He did it once.
And then you did it yesterday.
No.
Oh, okay. You
Today
did
was
it
the only day we didn't actually do it. Or yesterday.
Okay.
Paper instead.
We got 4 of them. We got cosine, sine. They're reciprocal, so now we need tangent and cotangent. So, again, couple ways we could do this. We could use this identity and do that same thing with tangent. Or now that we know sine and cosine, we could use this one too.
Let's do that one.
That's what I did. Yeah. That one's probably easier, the quotient identity here, that the tangent of an angle is just your sine divided by cosine. I know, sorry. Sine, we got negative root 5 over 3. Cosine was negative 2/3. Which, you guys have been doing this for a long time, right? That's how you've been finding tangent values. You've been taking y over x on the unit circle. Yeah, let's multiply by reciprocal for sure. For sure. Hey, does our answer come out positive?
Yes.
Yes, which they told me it does.
I found all of them.
Good job, Jackson.
Yep, so now we know tangent. Technically, again, you don't have to write down the identities. This is just more for your notes. Technically, that was the quotient identity. And then reciprocal identity, cotangent. Would be 2 root 5 over 5. Okay, yeah, these take a water. All right, do we feel like we need to do another one of those?
No, but I would want to.
You want to? Okay,
Yep.
I'll see one more. It's good practice. Okay. I'm giving tangent. What'd be easiest to find next?
Cotangent.
Cotangent, which identity?
Inverse.
Not inverse, not
Reciprocal.
inverse. Reciprocal.
That's like the same thing.
It's not the same thing. Okay. Oh, I should have pointed out. Looking at the information given to us in the original problem, tangent's positive and so is cosine. So what quadrant are we in? One.
Yeah.
Let's go.
Max is smart today.
Quadrant
All
one.
students take calculus.
Betcha. Okay. What do you guys want to do next? So all we know right now are tangent and cotangent.
Find sine and cosine.
So we're probably gonna have to do. So we use these. I can't do this yet because I don't know sine or cosine.
I mean,
So I'm probably gonna have to use one of the pi things.
gross. Let's go with the secant.
1 plus
Yeah, let's do this
Yeah,
one.
let's do that one.
Let's do it. 1 plus tangent squared of an angle is the same as the secant squared of that angle. That's one of our Pythag identities.
Kind of amazing things I'm doing
They're having a lot of fun. All right, we know we're given the tangent values 2/3.
I mean, we could make it that one.
Please.
What?
I only heard some of that, and then
You don't
But
want
I heard
to hear
that.
it.
You probably heard about it.
You don't want to hear it.
we can talk about it. Okay,
What's going on over there, Michael?
I don't want to talk about it.
Wow.
I am an educated adult. I can.
You can handle
Okay,
it?
yeah.
Alright. Can you though?
I don't want to, but I will if I have to.
Cover your ears.
Okay,
Heard about the birds and the bees?
let's do this algebra here.
That's a bad idea.
1 plus 4/9.
This is not exactly the sine C anyway.
Stop. Yeah.
Oh my gosh, I didn't.
That's why there's so much talking.
You're right, Megan.
I think it's
Good job, Megan.
Okay, guys, what's 1 plus 4/9?
1 4 9.
Yeah, that.
No, don't give me mixed numbers. What is this, baking?
This is baking. Yes.
Only time you ever use mixed numbers. I hate mixed numbers.
You use them in
Okay.
chemistry.
Square root both sides.
Open the door.
Natalie's notes.
I'm recording this for her too. I just, okay. So, oh, I put them up here, right here. That's her file. Oh wait, in one of these. Sorry.
That's a cheat sheet.
Cheat sheet. She'll love it.
I do.
Okay.
Dang.
So root 13 over 3.
Nice.
You say
Wait.
number.
Positive or negative?
Gotta be positive because it's in quadrant 1.
Wow, you're
Yes.
so smart. God, I wish I was as smart as you
don't
guys.
write very often, and when I do, I'm pretty
safe.
I'm pretty surprised.
We all have our own moment in the sun.
Oh shoot, this one is using X, not you.
It's alright.
we all understand.
Yeah, I was using you as well, so it's fine.
I mean, I used X at the beginning.
I've been using it.
Oh, is that why you said that,
You
Rick
said it.
Jackson?
Said what?
That's how I feel.
Oh, no, not that
Oh.
one.
No, he was just being Jackson, actually. Not that relation.
Secant of X.
You should listen to my forensics piece. I talk about grabbing booty.
How is this happening?
We're high schoolers, that's how.
Alright, what will be easy to find out? Yes. Ollie is like, let's not mess around.
3 square root 13.
Over 13.
Wow.
You are a different breed of smart, Max.
Which identity did you just use?
Reciprocal identity.
Reciprocal identity, good.
Me and Connor are tag team everything.
Alright, I want you guys to pick any of the identities to find the last two.
Okay.
I got
The last two.
We have that.
Cosine.
You could use one of the pi tags. I use one of the pi tags again, actually.
Can we use tangent? Cosine one?
You could do tangent and like algebraically solve for sine.
Yeah.
You could do that. Try it.
Oh, I have to physically do it?
Yep.
What?
Yep.
Bologna sandwich.
Oh,
No talking.
Wow.
Listen, I did have a question.
Make it ready.
So,
Helping.
can I like cancel it? Or no? Can I cancel the threes?
Yes.
I just did that.
Yeah.
That's all I got too. Bless you.
I'm doing it right.
I did sign correctly.
Bless you.
Am I allowed to answer questions? Will?
Shut up. From squaring this, I square that. That'd be 9 times that.
I give you fruit roll-ups. I shower you with affection.
What do we need to find? Cosecant?
Cosecant or sine?
We're jamming.
Now, some of you I know are using like the tangent one. What personally, like just for the setup of this problem, do you see how these two are nice, clean, like integers, and there's no radicals?
Yeah.
So I'd probably like use one of those again. You don't have to, but I did this next because I was like, hey, this is a nice, clean 3/2, and then I could easily solve for cosecant, and then I could easily solve for sine. But again, there's different ways. I see some of you were doing this, and you plugged in tangent, and you plugged in cosine, and then you solve for sine by just times by reciprocal. That'll work too. Yep. And then just flip it.
Yeah. That's awesome.
Okay, here's what I got. For sine, I got 2 root 13 over 13. For cosecant, I got root 13 over 2.
Oh, cool. I did do it right. Thought I killed the cat there for a second.
So I want to stress that there are like different ways you can get to the answer. There's not like one right way, but there can be ways to make it easier on yourself. All right. So my advice is if you're given nice, clean, whole number ones, that can make your life a little bit easier. But I saw, Wally, you did like the pi thing one was sine and cosine, right?
Yeah.
Did you still get sine x to be that?
Yeah.
Yeah, still same answer, just a little bit bigger numbers, right?
Yep.
Which identity did you use?
I just did.
That's a good one.
Okay, and then I like that tangent one, using the tangent one, that's probably pretty slick.
It's very slick.
Okay. Here's where it gets fun.
Oh.
No.
Good.
We don't have enough time.
Here we go.
Can't handle it.
So,
I'm having
these ones are like a puzzle.
Cards yet. I say we do it.
You want to go around with no cards?
These ones are like a puzzle.
We need like 5 minutes.
When I'm here, we're gonna do notes, because
We have the new
my
notes.
God. Use the fundamental identities to simplify this expression. There is more than one correct form of each answer. It's kind of weird, but sometimes there's more than one right way you can write your answer, and there's definitely more than one way to get to the right answer. So again, I'm looking at my list here, and you can look at your big list if you want, but I have cotangent over cosecant. And I'm like, how can I try and simplify that? And I'm like, okay, I could rewrite like cotangent as 1 over tangent, or I could rewrite it as cosine over sine. Like I could use any of these identities. And you're basically just gonna like try to rewrite them using one of the identities to see if anything like cancels out or simplifies. One of my pieces of advice is anytime you're given like the reciprocal identities, it's often helpful to rewrite them in terms of sine and cosine. So what I mean by that is for cotangent, instead of writing that as 1 over tangent, write it as cosine over sine. Yeah, that usually helps cancel some stuff out. Okay, that's like my first big advice. If you can, so let's write that down. If possible, you're not always going to do this, but try and write with sine and cosine. But like for example, like this one, we're actually not going to do that, but we'll get there. That's kind of one piece of advice. All right, so let's try one of these. So I look at my numerator, and that's cotangent. So I know cotangent, if I want to write it as terms in sine and cosine, is the same as cosine of that angle, which is theta, over sine. Yep. Okay, so this might just be something I try. And then my denominator, I have cosecant. How can I rewrite that? What is it? 1 over sine. And right now you might be thinking, Ms. Hendricks, you're not simplifying. This looks way more complicated. But instead of dividing by this fraction, we can times by reciprocal.
And then canceling out that sign.
And then the signs end up canceling. Yes, yes, yes. And this is actually just the same as cosine. Now that's not the only way to get there either. There's more than one way you can like arrive at that answer, and that's the part, like I said, that's tricky for students because sometimes there's like more than one way to get to the right answer, and it makes it really tricky to grade too because there's a lot of different ways you can do things. All right, let's try one more. Now this one is a pretty dead giveaway of which identity we're going to use. Of your identities, which one does that look like with the pi over 2 minus x?
Co-function.
Looks like a cofunction. So the cosine of pi over 2 minus x is the same as sine of that angle. The cosine of pi over 2 minus an angle is the same as the sine of that angle. So this is the same as the sine of that angle x. Cofunction identity. If you want to write the identities, you can. So now I have sine times secant. And I'm like, okay, this already looks a little bit more simplified. But can we go further? Let's change secant, to 1 over cosine. And then I get to here, which is the same as tangent.
Okay, these ones I kind of understand.
Yeah, these just take practice too. These take practice. And that's what we'll practice tomorrow more. But that's a good intro into our fundamental
I'm
trigonometry.
gonna throw this right there. What are you doing during our chat?
I have ACT practice.
Okay. Well, I'm gonna finish up on this.